Today we continue to talk about the measures of variation. Variation is a very important topic in statistics. In this section, we will introduce three important measures of variation: range, standard deviation, and variance. We will focus on standard deviation and variance. So our objective is we need to know how to compute the numbers. We also need to know how to interpret and understand the measures. So first, about the round-off rule for measures of variation. We always keep one more decimal place than the original data. Always one more. So first, let's check the first measure, range. So this is the definition. Definition of the range is the difference between the maximum value and the minimum value. The difference between the greatest value and the smallest value. So this is the formula show you how can we get to the range. Maximum value minus minimum value. So let's check the property of range. From the formula and the definition, we already know the range only uses maximum and the minimum values. So the range is also very sensitive to extreme values, because when we add some extreme value, most of the time the extreme value is just the minimum or the maximum. So the range will change dramatically, right? So the range is not resistant because it's very sensitive to extreme values. The second property is about the range is not very reliable, we will say, because it just uses the minimum and the maximum value, which means a lot of useful information has been dropped. So it's not very reliable, does not truly reflect the variation among all the values. Let's check how can we get to the range. Let's check this example. For example, this is our sample. In this sample, we have 5 values, and we just want to find the range of this one. So we only need to find which one is the minimum value first. So it seems 14.1 is the minimum value. And we also need to figure out which one is the greatest one. And next, we only need to use the formula. Use the maximum minus minimum. Then we can get the range. 41.50 is our answer. Okay, so let's move on to next measure, standard deviation. Okay, first of all, we will use S to denote standard deviation. Actually, denote the sample standard deviation. This S only for sample, so it's just sample standard deviation. And this standard deviation is a measure of how much data values, so measure how values away from the mean. So by the definition, we know we should get the mean first, then measure each value, how each value away from the mean. So that's the definition of standard deviation. Again, S only represents the sample standard deviation. If it's about the population, we will use sigma to represent the population standard deviation. Okay, S is just for sample, sigma is for population. You should know the difference, okay? All right, let's check the standard deviation. This is the formula. So in this formula, you will find this is sigma psi, right? This is sigma psi. So which means we should get the sum, but sum for what? Each time we should get the I don't know if you can see the parenthesis here. Each time we should get the value x, single value x, minus our mean value. We should get the difference between single value and mean value. Then take the square. So each value we should do this step. Then after that we should get the sum of the squared term. Then divided by n minus 1. N is the sample size. Remember how many values in our data set. So n minus 1. After that, take the square root. So this formula is just for the definition. It's not easy to calculate. We have another shortcut version to help us calculate. So in this formula, I'm not sure if in your PowerPoint you can see the parentheses or not. Don't know why here the parentheses are missing. So this formula is easy to calculate. Okay, if you want to do it by hand, I prefer use the second one. Okay, I prefer to use the second one. Of course, if you have the calculators, you can use the calculator and get into the statistic mode. You can use the statistic mode to easily get the standard deviation. It's not necessary to use any formula to get the standard deviation. So let's check the property of standard deviation. So first of all, it's just a measure. Each value deviate away from the mean. So just want to measure how far the value is away from the mean. How far values away from the mean. If we go back to check the formula, you will realize we have the square root in our formula, which means standard deviation is never negative. But it's possible to be 0 if all the values are the same. Values are the same. Then there's all the values are just the same, then there is no variation, right? So the standard deviation is just 0. So let's check the last one. Larger standard deviation means greater amounts of variation. So larger number means greater variation. If it's 0, that means it's no variation. No variation means all the values are exactly the same. Okay, let's check the next one. If we add one or more outliers, so that means we add extreme value. can increase dramatically. S can increase dramatically, which means this one is also not resistant. Not resistant. It's sensitive, not resistant. And the unit, we talk about the units of this measure, is just same as the original data. The units is just the same. So far, we learned lots of measures, measure of center and some measure of variation, something like range. The unit of these measures are just the same as the original data, but the next one will be different. And we should know the standard deviation S is a biased estimator. Is a biased estimator. What's the meaning of biased estimator? Let's check together. The values of S. So this is our estimator, S. Do not center around the value of sigma. So it's not center around the sigma. It is biased. Now let's check the example how to find the standard deviation by using these 5 values. So of course we can use the first formula. If we want to use the first formula, we should get the x bar first. Then each term, each x should minus x bar, then take the square. After that, we should get the sum of all the squared term, then divided by n minus 1. So you see here, we have 5 values. So n is equal to 5. Of course, n minus 1 is 4. Then we check the second formula. I say, if you want to do it by hand, I prefer to pick the second one. So for this one, we only need to find the x squared for the first one. X squared. So each x value, we find the square first, then get the sum of the squared term. So that's the definition of sigma x squared. Then the second term, we need to find the sum of all the x values. So we do the addition first. We get sigma x first, then take the square. So make sure you know there is a difference between these two terms. Of course, we will get the same answer as the previous formula. Right? So why we should learn standard deviation? Because after we learn standard deviation, we can use a rule called a range rule of thumb. We will use this rule to help us understand the data. So basically, we will get this conclusion. 95% of sample data values lie within 2 standard deviations of the mean. 95% of the values within 2 standard deviation of the mean. That's the range rule. So we can also use the range rule to determine a value is significant value or not. Then we check here, significantly low. When we can say this value is significantly low, according to the range rule, if this value is smaller than 2 standard deviation below the mean. So that is, this value is just 2 standard deviation below the mean or even smaller. This kind of values, we call it significantly low. Similarly, if the value is just equal to 2 standard deviation above the mean, 2 standard deviation above the mean, that's mu plus 2 sigma, or even higher than that value, we call it significantly high. But most of the data are not significant, which means most of the data are just between 2 standard deviation below the mean and 2 standard deviation above the mean. Above the mean. And here I say most value are not significant. Actually, it's just 95% of the data are not significant. What does that mean? For example, if we have 100 values in a data set, 95 values will be not significant. Only 2.5% values significantly low. 2.5 values significantly high. So if sometimes we cannot get the exactly number of S. If we cannot get the exactly number of standard deviation, which means some values are missing, some informations are missing, then we cannot get the exactly value of standard deviation. But we know what's the minimum value and what's the maximum value. So it's possible to get the range. Remember range, the difference between minimum and the maximum. So we use this formula to estimate the standard deviation S. After that, we can still use the range rule. So I said the notation S is just for sample standard deviation, and for the population, we will pick sigma to represent the population standard deviation. So, but here it's a slight difference between these two formulas. So when we talk about mean value, we know it's x bar equals, so this x bar is sample mean, it's sigma x value divided by n. So this is sample mean. And when we talk about population mean, it still need to find the sum of all the values, then divided by how many values in our population. They are actually the same formula, but with the different meaning, right? One is about sample, one is about population. But when we check the formulas for sample standard deviation and population standard deviation, we will find that they are not exactly the same, because for the sample standard deviation, we will use n-1 as the denominator. But when we talk about the population standard deviation here, the denominator is the n, do not have n-1. So that's the difference. But in your exam or in your homework quiz, we only calculate the sample standard deviation because it's almost impossible to get all the values in a population, right? It's impossible to get each value in a population to get the population standard deviation. So we always work on the samples. So make sure you know you should pick the formula for sample standard deviation, which means the denominator should be n minus 1. But why it's n minus 1, we can talk about it later. It's called the degrees of freedom. Let's check